Today I decided to just form a simple circuit where I have a combination of parallel and series. But my idea of setting this board here is to try and talk about this relay. We have a battery here, we have a switch and a relay, and then we've got bulbs, series connection, and then we have got a parallel connection. I'm more interested in talking about this relay here. It is a 4-pin relay, and I think I have a 4-pin relay somewhere. It is a 4-pin relay just like this one here. Okay, and if I can focus on that, let's see if we see the numbers. Can we? Not that clear. Yeah, we see pin 30 there, pin 86, 87, right? Okay, there must be a diagram as well, not on this one. Here, there is a diagram. I don't know whether we can focus, zoom into that. Can you? Can we getting somewhere? Yeah, camera is not the best. Anyway, so with this pin here, I'll just tell you what I have. You have number 30 here, 86, 85, 87. There's 87A here. 87A is meant if they are 5 pins, but we don't have 5 pins, we've got only 4. So we want to concentrate on 30, 86, 85, and 87. So I have deliberately, numbered these here. If we can zoom in, this is my battery here. So this is my pin 86. This is my ground, it's pin 85. This is 30, and this is 87. Right, let's stick with those numbers. So 86 is power. It is 12 volts coming from the ignition key and through the relay, okay, through the coil in the relay. And then 85 is the ground. Here is that's why I have this black wire here, okay? It comes back to my negative here. Okay, it is to ground that relay there, right? So that's the right. We just to finish off on the black wire. It's a ground for the relay. Okay, right. So for current flows through the coil and it comes back to ground. When that happens, once this relay is between these, this is what we call the control side of the relay. Okay. That's what we call the control side. So once current flows to ground, then a magnetic force, magnetic field is created, which then pulls that switch and closes. So what is it doing? What is happening whenever this switch is being closed? So you'll notice here something that I want to show is that 30 is permanent ground. Anything that is labeled 30 means that it is got battery voltage or source voltage, even if the ignition key is off. So can I prove that? I think I can. So if I put my ground here and then I come there, I have got source voltage. I've got 11.98 there, which I can get. See, that's straight battery to battery. And that same voltage is here as well. Okay. The difference between 30 and 86 is that 86 will only become live. You can check at the moment. Look at my 86. It is 0. But if I close that switch, 86 now becomes live when the ignition switch has been closed. The moment I turn the ignition switch off, then that 86 has no power, so there's no current flowing, then that switch is opened again. Let me dwell here because this is important. I've seen people struggle to test a relay. Okay. Let's pull out the ground. If I take the ground out, and then I want to close this switch, then we want to see what will happen to the circuit. So that's my switch closed. Listen, the relay is not even clicking. There is no ground. This coil is not grounded. Okay, we have power here on 86. Okay, look, if I lift, if I switch the ignition key off, we have 0. Switch ignition key on, okay, switch ignition key on, we have battery voltage here. But because it is not flowing to ground, that battery voltage has got, it doesn't have a ground. Okay, look what happens. Because there's no ground, that battery voltage will continue through the coil right to the other side, which is supposed to be the ground side, and you find that this whole system will be power. Okay, simply because we do not have a ground here. So I hope that is helpful. So if I can now I put my ground. These are some of the faults that we have. If they have no ground on the relay, this is what you're going to have. The whole circuit is grounded. But now I have fixed my ground, right? If I close, I want you to watch and listen as well. You hear a click. You hear that? So you hear a click, and then the whole system, this whole circuit now is functioning. But remember, the whole circuit was grounded by simply losing ground. Okay? Simply losing ground. The whole circuit, I'm still closing, the ignition key is on. But because we have no ground, right? There you go. How many times have you moved a wiring loom and you hear this click? You know, you start to hear things clicking. A technician, you know straight away when you do this, and then you go, you know that, man, I found a problem here. I'm close to what is causing the problem. Okay? So this is the ground. Let's look on the positive side. Okay? We want to look on the positive side. So we said this positive here on 86, it's only provided when the ignition key is on. Right, okay. Let's look at permanent live. Hot all times. Okay? So what do I mean? What I mean is, if you pull out this relay, then you go and check, you want to, with the ignition key on, you want to get at least 2 of those pins. You may not know which one is 30, which one is this, until maybe you look on the diagram here, this diagram on the relay here. It tells you which one is 30, okay? It will tell you which one is 30. But all I just do when I go to test a relay, I'm testing for my 2 powers. With the ignition key on, I want to find 2 12 volts, okay? Or source voltage, battery voltage. When I'm happy with that, now I go to, I don't even touch this one here, pin 87. Then I go to my ground. Then I check my ground. All right? With my ignition key on, I'll go and check my ground. Okay? Key on, check my ground. You can see the voltmeter is changing off. There's nothing. Key on, there's current flow there, as you can see. Right. So then I know that my ground, I don't I don't want to rely on this click. It can be deceiving sometimes. I've seen relays click and still do nothing. So do not think that when a relay clicks, everything is okay. So right, let's do this here. If, let's say we lose this power, this permanent live here, okay? If we lose this one, what happens? Okay, let me close. Listen, do you hear that? The relay is clicking. Why? Because when I close the ignition, turn the ignition key on, current will flow to ground. So this relay will respond. It is actually closing. It is closing, but look at the circuit. Nothing is happening. Okay, nothing is happening on the circuit because we do not have, we have this one. Let me demonstrate here. I think it's good to demonstrate. Right, we have this, look, off, nothing, on. So we have this power and it's being grounded. But look here, when we come here, we have nothing. So because of that, there is nothing now to flow to ground here or along these two circuits. I'm saying two because I've got my series and my parallel. Okay, so this is how important this live is. Now, because I have repaired my live, if I close that, the ignition switch is turned on and my circuit works. Right, so on pin 87, pin 87 is your load. So this is the 85 and 86 are the control side of the relay. 87 is permanent live. Sorry. Point of correction. 30 is permanent live. Our 30 is permanent live. And then pin 87 is our load, LOAD. Okay? It could be the starter motor. It could be the headlight. It could be a bulb. It could be anything. It could be anything that is being turned on. 87 is anything that is being switched on. That's going to consume our voltage. Okay? I hope I've explained this one clearly. I've been going so slowly so that I can try and provide some clarity here, because I have seen a lot of people struggle with the relay. So let's do this. The other thing that you can do, if you have got two relays the same, and one you suspect the other one is not working, it's clicking but it's not working, what you can do is, I would advise you to go check resistance. Go check resistance. So what we do, we come to pin 86 and pin 85, which is the control side. 85 and 86, they are the control side. So that's where we go, and then we tap into that. Oh dear. Sorry for that. We tap into that. So those are our ohms. Okay? So if I take another relay that is slightly heavier than that one, you can see it has got these two heavy terminals. One is 30 and the other one is 87. So this will be permanent and this one will be our load. So if we come then to these two here, that's our resistance. So just get two of these relays the same, just test, and then you should be able to make a conclusion as to which one is working or the other one, or both of them are okay. So that's right. So it's just to help you to make a determination. And sometimes it is good to swap them. swap them around. You know, I can put a mark, like I've got a mark on this one, so that I remember that this is the one that I'm suspecting, the one that I'm thinking is fault. Swap it with another one that is the same as this. See if the problem moves to another circuit and the one that was giving you bother now starts to work. Then you know that the relay is the one that is to blame. Right. So before I conclude here, I just want to point out at something. I have got two circuits here combined. These bulbs are of the same resistance. I think if I'm not wrong, they are 2 ohms. You'll notice that, let me put this one away. You'll notice that, look at the brightness. These are the series ones. Look, this one is a parallel one. A parallel one is brighter than the series ones. Okay? Right. We want to look at something here. If we come to a parallel circuit, I've selected voltage there. If we come to a parallel circuit, ignition key on, we get the source voltage. Okay? We get the source voltage across the load that is connected in parallel. But if maybe let me do this here so that I can just talk about something that, right, I'm now checking this bulb that is in series with this one. Check and see that negative. You see that negative? Can you focus? Try. Yeah, that's good. That negative shows me, it shows you that your probes are not connected the right way. You have swapped them. So if we can move, put ground this side and power on that side, we'll still get the same reading, but now we got rid of the negative sign. Okay, so we said our voltage here was 11.7 something or 11.8, but across this bulb here there is voltage drop, which we can calculate. Okay, to find the voltage drop, we just subtract that from the source voltage, which was 11.7, 11.8. Then we get the voltage drop. But if we come here again on this one here, that's our second load on the series side, we are getting 5 point something. 5.8. The reason is because these bulbs are of the same resistance, so voltage will drop the same. But if I can do that, if I can combine both loads now, the 2 voltage drops, if we put them together now, they'll give us source voltage. So in a parallel, in a series circuit, if you add all the voltage drops, all of them, they will give you total load. Sorry, not total load. They will give you total source voltage. So if we had 3 bulbs connected in series, we just go and not take down all the voltage drops across. You'll find that if you add the voltage drops, they will give you what the source voltage is. So, right, it's interesting to see that your parallel circuit has got brighter lights than the series, because here you are adding the resistance. So the resistance here, it will be that resistor plus that resistor. That will be the total resistance of the series. But here we have one resistor. Okay? If we add another one, you will find that the resistance will be even less if it's in a parallel circuit. The more branches you have in a parallel circuit, the lower the total resistance you are going to get. Okay? It doesn't. Sometimes you might think, hang on. We are adding, resistors. Well, how come, they are going to be less? Yes, it is true. In a parallel circuit, the more resistors you have in a parallel circuit, the less the total resistance. And also, it is true that your total resistance will be less than the least of those resistors that you have in a parallel. So if your least resistor was 1 ohm, maybe you've got 5 resistors, and your least resistor is 1 ohm, it means the total resistance of that circuit will be less than 1. All right? I hope you have enjoyed this little session or tutorial or lecture, whatever you want to call it. I think especially concerning the relay, you should be able to test the relay with no issues at all, because I have clarified really how a relay works. You take it like that, you'll never go wrong when you diagnose your relays. And also between the parallel and the series circuits, it is true that you add these together, and then the total resistance, because of total resistance, you'll find that current that flows in this line of the series will be less than the current that is flowing in a parallel, due for the simple reason that we have got higher resistance in a series circuit. Do not forget to subscribe to our channel. Thank you for participating. Please click the notification bell so that the more of these videos that I will be posting, you are not going to miss any. I'm sometimes posting 2 videos a day, and I'm hoping that these are helping people out there. That's how we learn. We learn from others. So remember to give us your comments. We welcome your comments. If there's anything that you think I left from this video, I'll be interested. I'll be happy to hear from you. And we always take those comments on board. Thank you very much.